Welcome to my ethical hacking. This is chapter 10, IDSs, Firewalls, and Honeypots. Again, this is just overview study material. In this chapter, we are looking at identifying IDSs, their components, looking at Snort. We're going to be describing firewall types and their functions, describing honeypots. So, when we're talking about IDSs, it's an intrusion detection system. It's passive. It's used to monitor network traffic, mainly to detect unauthorized access, and it doesn't really do anything. I mean, it may notify you, but it doesn't take corrective action. That's an IPS. Within our IDSs, there are two major types, network-based or host-based. So we can have a dedicated network appliance, or we could have one on a host, essentially. So IDS components, it's going to have some type of sensor. It's going to have a monitoring system that's going to be centralized. Part of that monitoring system will be its database and its storage. And then it's going to be able to do response and response boxes, as well as reporting. The sensors are a big part because that's going to be where the monitoring system pulls its data from. And that means we're going to have to talk about sensor placement. Where along the network is that data going to be pulled from? So, how does an IDS work? We're looking at maybe it's an anomaly detection. It could be based off of signatures or by patterns or even protocol decoding. So with anomaly detections, we're going to be looking for profiles. That's going to be both authorized and unauthorized access. Essentially, it's going to be a learning mode. It's good at spotting behavior that is abnormal, though this takes a lot longer to configure because it has to learn what's normal. If we're looking at the protocol system, that's going to be based off of things like actions of TCP/IP, for example. Pattern matching or signature matching is going to be based off of a known signature database. That way, if X signature comes, it means it's the set of an attack and move from there. The most common is going to be Snort. Snort is a freeware IDS program, and it's both in Windows and in Linux. It operates as a network sniffer, and it's based off of signature activities as well as matching activities. You can generate or create your own Snort rules, and the rules could be headers or options, depending. What's really interesting is you can create basic rules like what type of action. If this event happens, do this. If this event happens, log this. Things of that nature. The rule options are going to be used to identify the rules and the alert messages, even though it's not required, it's more of an add-on. I'm hoping that my next set of videos will be Snort in detail, because Snort is actually extremely powerful. We can use common keywords in Snort to help match content or to help match payloads or specific items. That way, if we want to have Snort match flags or IP headers or TTLs in an IP header, we have predefined keywords that help us configure Snort a little bit easier. So, how do we evade IDS? Part of the invasion techniques could be like flooding. The evasion process, again, the IDS is going to discard the packets that is accepted by the host to address to. So we can actually do some spoofing to do that. With flooding, the attacker attempts to overload the IDS by flooding it with traffic. That way, while it's being flooded, it may let traffic that it wouldn't normally let through. Sometime like a DDoS attack or a DOS attack is actually just the invasion process to overload the equipment so that the real payload or the real vulnerability could be executed. Session splicing, that's where the payload is a fragment and delivered over multiple packets. That way, if we're looking at signatures or patterns, it's harder to figure that out. So IDS attacks, very big false positives. That's where you get a positive that's really false. Session splicing we just talked about, some type of DOS attack or obfuscation. That's always a big one. Our pre and post connection within our sync, that's going to be part of our TCP handshake. Some of our evasion tools could be tunneling or network IDS bench or even Nessus. So moving away from IDS, let's talk about firewalls. What's a firewall? Firewall is hardware or software that's designed to limit or filter traffic as it either enters or exits, as its egress or ingress. We normally have several different types of firewalls. One of the big ones is going to be a packet-based, and we're going to filter the ACLs so that we can filter, block, or accept traffic based off of a criteria. Firewalls do not prevent spoofing. They normally do not inspect payload unless it's a specific type of firewall that actually does payload inspection or deep packet inspection. It doesn't keep up with the state, meaning it cannot tell if a connection started outside or inside of an organization. For whatever reason, NAT's here. NAT is network address translation, and it is the mechanism that actually translates between private and public IP addresses. Not really a firewall feature, but it's here for some reason. So we're also looking at applications and circuit level gateways. They can be sitting between our end nodes and our web servers. While it does reduce traffic, it does increase security, it does include overhead. So when we said it doesn't need deep packet inspection, we actually have this item called stateful inspection, and this does keep track of the status of a connection, and it does maintain a state table that records a connection, and stateful with deep packet inspection can analyze detailed packets. We also have a DMZ, or a demilitarized zone. This is going to be a special zone type. So if we are looking at an outbound or inbound or WAN side and LAN side of a router / firewall, the DMZ is going to be that gray area in between. For example, if you have web servers, you're going to want outside access, but not the same level of access you would want on an internal LAN. So we actually create this DMZ zone to put outbound or out-facing web resources, like an email server or a web server. That way, they're never actually connecting to the LAN for these resources. Identity firewalls. There are three primary methods: port scanning, firewalking, and banner grabbing. Essentially, port scanning, it's going to be one of the most common ones. Firewalking, basically firewall discovery tools that crack packets with a TTL. That way we can see the hops past the firewall. Banner grabbing, again, it's going to try to connect to certain services using a specific port that is there. So it's could start off legitimately. They actually try to grab the banner. That way you could see what information you can pull from it. All the firewalls are going to have a unique characteristic to their model, to their brand. And so if you know those unique characteristics, you can know what type of firewall you're dealing with. So that's an example. So bypassing a firewall, normally firewalls do not prevent attacks, especially attacks that are things like inside or internal hacking, attacks from a secondary connection, any form of social engineering or physical security, or even very poor management, policy, or configuration of that device. Firewalls only do what you program them to do. Things like the ACLs, It's up to the network administrator or the network person to configure the appropriate firewalls to block or to allow the traffic that they want. So things like trivial FTP could be used to hack a firewall. We can use that to basically copy additional code to our firewall to function. HTTP configuration, if we're looking at some form of web access or web management of the device. Trojans are another way to bypass a firewall to pretend to be a legitimate program that an end user does actually activate. All right, so one of the last major topics is these things called honeypots or a honey net. So a honeypot is a singular device that basically acts as a drawl. It may pretend to be a soft target, something that an attacker may really want. The purpose of a honeypot is to do things like provide advance warning, maybe track the attacker, maybe even figure out how the attacker is getting in, learning some of their methodologies. Maybe it's luring the attacker away from legitimate users to attack this fake system that they may want more. If we're talking multiple honeypots, we could call that a honey net. Common honeypots are like Spectre and Libri or Tiny Honeypot. There's so many of them. The issue is it's hard to tell real traffic away from this fake traffic, and so a penetrate tester may get stuck in these honeypots because it's data that's really good, that it seems to be what we want, but it really isn't. So how do we detect honeypots? We could use things like Nessus. Nessus is a huge item. Normally, attackers can detect the honeypot is not real by probing the services, by looking at their load, by looking at the traffic. And that's actually it for this chapter. Again, this is not a in-depth, this is just a quick overview of the material. I want to